Assalamualaikum and hi. In this video, I will explain on how to solve tutorial chapter 1, question 8. Okay, so we proceed to the question. The question asks you to verify Stokes' theorem for the vector field B equal to R cos phi AR plus sin phi AV. Okay, part A, you need to do a line integral. Okay, over the semicircular contour shown in figure below. So we have this figure. This is differential length. You need to calculate the differential length for the semicircular contour. Okay, so we know that we have three lines. So the first line is DL1, okay, which is refer from 0 to 2, and then we have DL2, refer to 0 degree to 180 degree. Okay, and then we have DL3 from if we see the arrow, it is from -2 to 0. So we need to do the differential length. Okay. First, you need to add all the length here. So you need to do integration of vector B dl1 plus integration of vector B dl2 plus integration of vector B dl3. Before that, we need to determine what is dl1, dl2, dl3. So dl1 is referring to the dlr because this one is the radius. It's follow the radius direction, the length of the line. Okay, and then we have dl2 is follow the phi. Okay, the length of phi here, and then dlr is follow the radius here. Okay, same with the first dl1. Okay, now we need to substitute all the values, not the values, all the equation. So we have B, vector B. So this is the vector B. Substitute all the vector B here. And then for DLR, okay, DL phi and DLR here, you need to refer to the table given. What is DLR for cylindrical coordinate system? Okay, DLR is DRAR. Same with this one, DRAR. Okay, for DLP is RDVAV. So first, we need to monitor here. Okay, AR dot AR is equal to 1, but AV dot AR equal to 0. So automatically we can remove these terms. Okay, for the second part here, AR dot AV is equal to 0. AV dot AV equal to 1. So we maintain these terms and we remove these terms. The third part is AR dot AR equal to 1. Okay, leave it. And then AV dot AR equal to 0. Cancel out. Okay. So next, just solve it. The integration, you will get like this. And then substitute the value of R, the value of phi. Okay, substitute. You will get, the answer is 8. Okay. This is for question 8A. Okay, we have question 8B. In order to verify Stokes' theorem, the previous answer, which is 8, okay, this is 8, you get 8. So you want to apply Stokes' theorem, so make sure that this equation, the solution must equal to 8, so that you can prove that this is Stokes' theorem. Okay, so okay, first we need to solve the del cross B. So refer to the table given. Del cross B under cylindrical coordinate system. So this is the equation under cylindrical coordinate system. Okay. Okay, next, before that, okay, I want to show to you, okay, this is vector B. So this one is the magnitude. Okay, this is the magnitude. This magnitude is referring to the R direction. So this is BR. And this magnitude is referring to B, direction of V. So this is BV. So I will put it here, BR equal to R cos V, and BV is equal to sin V. So we don't have BZ. BZ, no BZ. Okay. So you just need to cancel out BZ. So BZ does not exist. This one BZ not exist, and only V and R, BV and BR is exist. And substitute the equation here, BR, R cos V into this one. Okay. And then substitute BV equal to sin V. Okay. Okay. So substitute, you will get like this one. Okay. Direction of AZ is still exists. Okay. Because if you refer to the equation, AZ is relates to BV and BR, not relates to BZ, magnitude of BZ. Okay, it's different. So just proceed, do the differentiation. You will get the answer is 1 over R sin phi plus R sin phi AZ. Okay. So you get del cross B, and then substitute del cross B into this integration. Okay, integration part. So that's why you need to do this one, integration. Okay. Okay, so you already substitute this one. Okay. How about this? DS, differential surface. So we know that this surface is facing towards, Z. Okay. If you can imagine 3D, okay, we have X, Y, and Z. Z is like this. Okay. This area may be at the bottom of Z or maybe at the top of Z, axis, and it's facing towards Z. So this is DSZ. Refer to the table. This DSZ for cylindrical is R dr dpaz. So now we can solve it. Okay, you can cancel out this R. Okay, and then solve towards the first one. You need to solve towards dr. Okay, and the second part you can solve it towards dphi. Okay, this one you can solve it towards dphi. Okay, at the end you will get the answer is 8. This one is just solve it using simple integration. Okay, you can do it by yourself. Okay, because this is you had learned in your secondary school. So the answer is 8, and it's verified that this is Stokes' theorem. Okay, thank you.